Today's video is titled How to Implement Quadtree Meshing in TUFLOW. There'll be three separate segments to the video. Initially I'll introduce what Quadtree is. I'll then show you how to implement it within a model, before then stepping through two separate benchmarking exercises to demonstrate the simulation speed up that can be achieved using this feature. Let's start with what Quadtree is. It's a new feature in TUFLOW as of the 2020 release that will enable you to refine your mesh resolution by dividing a single cell into 4 down 9 levels. And in doing so, by using this feature, you can increase your mesh resolution wherever you desire within a model. How do you implement it? To start with, you build a single resolution model. Here we have an urban situation where we have an underground pipe network in 1D linked to a 2D grid for the above ground definition. Once you've established your single resolution model, it's really just a matter of introducing a new control file titled the Quadtree control file. It will contain all of the new files that you need to implement Quadtree. Let's look at that file now. There are 4 commands which you need to be aware of. Of these, the top 3 can actually simply be used to pull information from the TUFLOW geometry control file by assigning a variable acronym of TGC. Alternatively, you could overwrite those values if you wished. So that's for the model origin and extent, orientation angle, and base cell size. The 4th command listed there, reGIS nesting, is a spatial dataset where we'll define the location of our nesting as well as the level of nesting which we would like to apply. And here's a worked example. We have the green polygon that defines the location where we'd like to find a resolution, and within that polygon there's a single integer value to find the level of nesting that we'd like to select. In this instance, level 3. There you can see the dark blue grid is the finest level. That's adopted a 3 meter cell resolution, and TUFLOW then automatically graduates out to the parent cell resolution, which was the resolution that was defined in the TGC in this instance. That's all that's needed. TUFLOW will automatically assign all of the boundary conditions and other features that you had included in your single resolution model. And that's very useful in this case here in an urban situation where we have literally thousands of 1D2 linkages. The scheme automatically assigns those to this new Quadtree mesh. The previous slide demonstrated the automated mesh approach which TUFLOW has. You can also use a manual approach where you'll have total control where the graduating from your finer resolution to your coarsest resolution occurs. And that is done by using a series of polygons. In this instance I have a level 3 polygon which is green, and then overlapped on top of that is a level 2 polygon. So instead of graduating up from the finest resolution in the quickest amount of time, I've provided a wider buffer around this particular feature in the model where it's got a level 2 nesting. The simplicity of the application makes this feature really powerful. This is an example here where you have quite a large urban model. In the space of 10 minutes, by simply using the road network dataset which Council provided, we'll be able to convert that from a single resolution model to a Quadtree mesh model. Let's look at some of the metrics from that model. The model area was 12 kilometers by 10 kilometers in area. The event that we ran had a 17-hour duration, and the approach that we adopted was rain on grid, where water is applied to every single 2D cell in the model. This model also had in the order of 3,500 1D pipes, so it had the whole stormwater network in it as well. At a 3 meter cell resolution, it had in the order of 6 million cells. When we used the road network to define the Quadtree nesting at 2 levels, the number of cells reduced down to around 2 million, and with 3-level nesting, we reduced the number of cells down to 1 million cells. That has pretty significant implications in terms of the amount of GPU RAM that's required to establish the model. It also has significant runtime implications. we reduced the run time from 10 hours down to 4.5. The simulation speed results is one thing. Looking at the actual end model results is another. And we'll do that by comparing the water surface elevation result from the Quadtree model against the single resolution simulation. That single resolution simulation result is shown there on the screen in front of you. In addition to that, I've sampled the difference results at all the inlet locations for the pipe network. So it's in the order of 3,500 sample locations, and I've taken that result and plotted in a histogram, and you'll see that in the following slide. Here are the results for the level 2 nesting. On the right you can see it's mostly yellow. That basically means that there's next to no change in result. The accuracy that you achieved in the single resolution model has also been replicated in the Quadtree mesh model. And plotting that in a histogram, we can see that in 86% of the locations, the result was within plus or minus 0.1 of a metre of another. It's quite a good correlation. Now looking at the level 3 nest result, they are very similar. On the right you can see it's mostly yellow. There is some colouring here and there. When you look at the histogram result, it's 82, there's an 82% agreement within that plus or minus 0.1 of a metre comparison. Looking at the left-hand side of the histogram, there are a few values that show a pretty significant difference in results. That's in the order of even up to 1 metre difference. If I was to do this modelling for a project, I'd actually isolate out those areas and then look at them in detail to see if a finer resolution mesh is needed there. I expect that they're in locations that currently have a 12 metre resolution, and I'd bring that down to a 6 or a 3 metre resolution just to get a more accurate result. The second benchmark I wanted to show you is a fluvial assessment. We have river flooding, the water levels in the river rise, break out of bank and then flow into the floodplain. The catchment is 18 kilometres long, also 10 kilometres wide, and the event was a 72-hour flood. At a 7.5 metre resolution, this model had 1.3 million cells. If we embed nesting in the rivers and creeks at 2 levels, the number of cells reduced down to 400,000, and if we use that delineation for 3 levels of nesting, we get it down to 200,000 cells. Similarly, that has pretty significant RAM implications for the model initialization and also simulation time benefits. We've halved the simulation time from 4 hours down to 2. In a real-world study, I'd be a bit more discreet in my nesting, so I've decided to give an example of that here, where I noticed that the 3-level nesting was perhaps overkill in the river. There was already enough cells across the river to adequately define that at a 15 metre resolution. So with that in mind, I used a 15 metre resolution through the river. In the smaller creeks, I used a 7.5 metre resolution, and then everywhere else remains at that coarsest 30 metre resolution. And in doing that, I've reduced the cell count down to 130,000. The GPU RAM is pretty insignificant, and the simulation speed has increased 4-fold from that original model. This model runs in 1 hour. In the interest of time, I'll just present the results for that final simulation, where I used both a combination of the 2 and 3 level nesting. The results are excellent. We're seeing almost complete agreement between this model result and the original single high resolution model simulation. In 99% of cases, the result is within plus or minus 0.1 of a metre. To sample data for this histogram, I've actually extracted a grid of results for every single 100 metres across this entire wetted area. That concludes my presentation. As you can see, Quadtree is a very powerful feature and something you can use to significantly reduce your run times and also your memory requirements. If you have any questions, please feel free to shoot me an email. My details are on the screen there, chris.huxley@tuflow.com. Thank you.